In the previous video, I spent considerable time walking through the steps in solving a system using elimination. And what I want to do now is, perhaps with some more brevity, just do the same computation and show you how you can use matrices to do it. And point out some things that you probably didn't think about or you haven't thought about as you solved these in the past. So the first thing I want you to notice is that in this whole process, the x's and the y's, as written, are somewhat not really needed. And what I mean by that is this. Take a look at our final answer down here. Right? 1x plus 0y equals 2, and 0x plus 1y equals 4. So long as we understand that the numbers in the left-hand column represent the x coefficients and the second column represent the y's, as long as we go in knowing that, we don't really need to write the x's and the y's. So this in blue, what I'm going to write at the bottom is basically code for exactly what I have here at the left. So 1, 0, 0, 1. Those are the coefficients of my x's and y's. I'm going to do kind of a little dashed here, a vertical dash line, and then a 2 and a 4. So long as we understand that this is the x column, and this is the y column, and this is the answer column, then writing the x's and the y's in solving this is not really necessary. And that's where matrices kind of come in here. Because we're going to do basically everything we did here on the left-hand column. We're going to do all that. We're just not going to be writing the x's and the y's in. And our goal is going to be to turn the matrix we start with into this one right here. Because once you've done that, you've encoded at this point, 1, 0, 0, 1 with the answer column as they are. You've turned the matrix into this form, and now you know your answers. So, to begin, our first step, or our original matrix, is going to look just like what we have there on the left, but we're not going to have the x's and the y's. So here's the understanding. I've got a 2, a 3, the coefficients of my x's and the y's, and then I've got the 4 and the 5. I put a little dash line there, and then put the answers 8 and 28. Again, as long as we understand that this is the x column and this is the y column, then this is really just the matrix form of the equation we have over here. And actually, I think it's a -2, -2x. Right? It's just the matrix form of what we have over here. And now I can just do all the operations that I have written in the middle. I'm just going to do them to the matrix. So I'm going to add the two equations together. I'm going to multiply the top equation by by 2. So I do that. I'm going to put a little 2 there, and now the new equation looks like this. Or the new matrix will look like this. Right? And remember, all I'm doing now is I'm doing what I said in 2 videos ago, how you can add equations together, you can scale them by numbers. You're not changing the values of x and y. But since the coefficients are really the only thing we're focusing on, then again, our goal is to just get our matrix in this form, and then we'll know the answers, this form down here at the bottom. So what was next? We added the two equations together. So let's add the top equation to the bottom equation. You know what? Messed up, because I just found a mistake. And hopefully you found it too. Sorry, this should be a 6, and that should be a 16. There we go. And now I'm going to add the two equations together. So when I add the top equation to the bottom equation, I get a 0 down here, right? The bottom equation, those -4 and the 4 cancel. 6 plus 5 is 11. And 16 plus 28 is my 44. And I'm going to keep the top equation as is. I'm going to leave it as -4, 6, and 16. And it might make you uncomfortable that I did that. I mean, you might have thought, well, you just added the two equations together. Shouldn't that produce one new equation? It does. It produced this bottom equation here to produce that bottom row. However, we can keep whatever version. I mean, any of these rows that I have here above, any row of any matrix represents a legitimate equation or a true statement involving x and y. So I can keep whichever ones I want. And so I'm going to keep the ones that are going to make it more likely to get that I can get the matrix in this form here at the bottom. So what was next? We multiplied the bottom equation by -6 and then added it to the top. But before that it looks like we multiplied the bottom equation by 1/11. So I'm going to put 1/11 here, and then the new equation becomes, or the new matrix becomes, I got -4, 6, 16, and then I got a 0, a 1, and a 4. Okay, and then I multiplied the bottom equation by -6. So I'm going to put a -6 here. Multiply the bottom equation by -6. So I'm going to write what that changes it into just underneath here. 0, -6, and -24. And then add that to the top equation. So when you add that to the top equation, you get 0 plus -4 is -4. -6 plus a 6 produces a 0. And -24 plus a 16 produces a -8. And we're going to leave the bottom row as it is. And then the last step you'll notice was to multiply the top equation by -1/4, I believe. -1/4. So when I do that, I get this exact matrix at the bottom. So we just solved that entire system, if you look at the right-hand column, never really having to deal with those x's and the y's. And it became sort of a game of turning our original matrix here, which kind of encoded our equations over on the left, using those basic rules of multiplying and adding the equations or the rows together to turn it into this bottom. Because when you get it in this bottom form, as you can see over here on the left, that corresponds to what your x value is, in this case 2, and what your y value is. So in the next video I'll do one just using the matrix form and show you in a system of two equations and two unknowns how sort of the fluency of this process in using matrices. And then later we'll do it with 3x3s. But so again, just I know that's kind of a lot to take in at this moment, but just see if you can at least buy into the idea that using matrices to solve systems is legitimate and also often useful and quicker.